Okay, I'd like to get started, please. We start out with 4.5. It's about integration using U substitution, okay? It's a different technique of, yo, Joanna, what's up with you, girl? God, you really changed, man. You become a real serious senior here. Huh? No, of course not. Not on a Friday morning. Not in math, at least. You can do it in ethnic studies, yes. What? Wow. Okay, do. Cindy, do. Done? Oh my God. Katrina is just writing the problem down here. Wait, give us some time. Yes. Not half, the entire class, except for Layla. Okay, Layla, and the answer be? X cubed over 3 plus x plus, nice, plus c. Don't forget the c. Someone did. No, I think even that dude did, I think.
Really?
I think.
I didn't do C.
I think.
I did C on everything.
Yeah, you did see. You did see when you had to differentiate. You put a C down. Get it. You put a C when you integrate, not when you differentiate. Oh.
Do I get a lot of points off of that?
Of course.
It's good. I have like the animal, so like it has like a tail. So. Like if you're asking for a dog,
Okay. Do next.
Oh, just skip all. No, like I was not gonna.
Okay, Henry Chupkar now.
Why should you put the quiz in the quiz category?
The quiz in the quiz category? Oh. Yeah, I don't know, for some reason all the weighting got screwed up. I don't know how it got screwed up. No. Can't do. Yeah. Done? I don't think so, no. He did fine. Leo, done? Dare you? Never give up. Janice, you done? Okay. All right. See how the clock there is ticking? Yeah, it's ticking you off, isn't it? Get it? I got to fess up on this one. Okay, that wasn't mine. That was who was it? It was Chris Trin from period 1.
Oh my God.
Sorry? What? Okay, so what do we do here? Well, guess what the topic is today? What's the topic? U subst. U subst. So one of the hardest part in this topic here is what do you U subst for? Okay? Which of these do you write a U for? That's the hardest part. Okay? So, and the only way you learn that is if you develop, my heart's here or here? My heart's somewhere out here. You develop what? Yeah, you develop feelings. And Henry, the way you develop feelings for these kind of problems is not to hang out with chicks at Starbucks, but to hang out with math. Okay, you hang out with math, you hang out with these problems, you shall develop love. Okay? So, my U subst is going to be U equals x squared plus 1. That's my U subst. Okay? And now you're going to differentiate this with respect to x, so you will get du over dx is equal to 2x. What you're going to do now, can someone take him out? No, just do it right here. Just right here. Oh, take my AK-47 out. Hey, man, I've got some spicy guns here, man. Bag of spicy food here, okay? So I want to kill Henry. That's all I need to do is give him some of that food. Okay, so what you want to do here is you really want to split this up as du equals 2x dx. And here's the reason why, okay? Do you see how there's an x dx in here? Do you see that? It's not next to each other, but you know that 3 times 2 times 5 is 3 times 5 times 2, right? You can change the order, right? Right?
Yeah.
Okay, so x dx is not together, but you know you can always put it together because they're kind of multiplying, okay? So here's my x dx. You guys see that? Yeah? So can I say that x dx is equal to 1/2 du? Is everybody okay on that? Dividing both sides by 2. Yeah? Okay? You guys with me on that? So if I come back to my integral here, I can write x dx as 1/2 du. I can pull the 1/2 outside. Can pull the 1/2 outside. I don't need to keep that inside the equation. And instead of square root of x squared plus 1, I'm going to write square root of u. Nice. How do I integrate this? What's the first step I need to do? Sorry? 9. Write it with an exponent. And I know how to integrate this now. Henry plus C. Okay, that's u to the 3/2. Well, u is your variable. That's not what should stay at the end. So what should you replace it with? Nice. So it's going to be 1/3 x squared plus 1 to the 3/2 plus c. And you can rewrite this as 1/3 square root of x squared plus 1 quantity cubed plus c. Okay? The 3/2 I'm writing it as a radical. Okay? 3/2 I'm writing as a radical. I mean, if you don't take the last step, I'm okay with it. Question later.
So you replace x squared plus 1 with u.
Yes.
And then you differentiate it?
Yes. Well, the reason why you differentiate that is you can replace the stuff that's in yellow with stuff that you got out of this thing here. See, there's yellow there, and there's yellow here. You can replace that yellow with what you get out of there. Okay? I'm going to do several examples, so hopefully this will become clearer. Okay? All right? Yes? Sorry? I'm saying the step from here to here is optional. Okay? Okay, next problem. So I'll do this one too, and then you'll do some others, okay? Now in this one, there is really no choice for a u except what? Yeah, it's kind of fairly obvious that that's the only thing you can do. Then du is equal to 2 dx. Remember, you're differentiating with respect to x. So in these substitutions, you should always have a du and a dx. Sorry? Du is the derivative of u, and dx is the derivative of x. Yeah. All right? So notice that you've got dx here, you've got dx here. So I'm going to write dx as 1/2 du. And then you go about your substitution business. So then this guy becomes equal to, and instead of square root of 2x plus 1, I'm going to write square root of u. And in place of dx, I'm going to write 1/2 du. Notice that on this one here, there's just u. There isn't a u and an x. I never want to see a u and an x together under the integration sign. It's either all x's or it's all u's. Okay? Don't do a hybrid there. Well, you know how to integrate this. 2/3 u to the 3/2 plus c. And then replace the u with what? Going the extra step. Okay, you guys with me on that? Right? Okay. Next example, I shall leave to you to do, or shall I do? I shall do? Okay, and then the one after that, you shall do. Okay, well, let's see if you developed some love by now. Cindy? Sorry? Nice, x cubed plus 1. Good job. So then du is equal to? Good job, Tati. 3x squared dx? Good job, Tatiana. So notice here. Okay, you with me on that? Yes? So from here I know that 1/3 du equals x squared dx. So then this guy becomes equal to 1/3. And in place of square root of x cubed plus 1, I shall write u to the 1/2. Okay, I'll replace the square root with a half. Okay, just a step ahead. And then x squared dx gets replaced with 1/3 du. Notice how I pull the 1/3 out of there, okay? 1/3 out of there. Okay? And again, we know how to integrate this. Integral of u to the 1/2, 2/3 plus a c. Okay, so this becomes 2/9. And then it becomes square root of x cubed plus 1, 180 cubed plus c. Is everybody okay on this? Yeah? Jonathan? Today is not senior cut day, right? People at the blood drive thing? That's where Laura is, and who else is there? Who? Oh, Lucy Goose is there? And who? Oh, Nitya. Okay, is everybody all right on this? All right, so now you get to do, okay? Different topic to start out, okay? Solving differential equations. Okay, we've done this. We've done simpler versions of this way back in chapter 3. Oh no, we couldn't have done it in chapter 3 because this is all in chapter 4, so maybe in the beginnings of chapter 4. So first of all, does everybody understand why it's called a differential equation? Why is it called a differential equation? It's got a derivative and it's got an equal sign. Okay, so that's why it's called a differential equation. And the idea here is to solve y as a function of x. Okay, so you want y equals some stuff of x. So what this means is you're going to isolate the y's and the x's. Okay, so right here I'm going to rewrite this as dy equals 4x plus 4x over 16 minus x squared dx. Right? In other words, I've got the y on one side and I've got the x's on the other side. Yeah. Hang on. Okay, right? You guys with me on that? Well, you can't leave it like this because this doesn't mean anything. You need to integrate this. You need to integrate that. Okay? So now here it is understood that this whole thing here is to be integrated. So parentheses are not necessary. It's implied. Okay, it is implied. All right? And if I integrate dy, what do I get? Nice. Good job. Good job. If I integrate 4x,
2x. I mean, no. 2x.
Thank you. 2x squared. Thank you. Now I'm going to pull this 4 out and then do this integration here. And for the last one, I'm going to need a u sub. Okay, for the last one, I'm going to need a u sub. You guys make me a suggestion. What do you want me to u sub? Which one? 16 minus x squared. So then du is equal to nice, good job. So again, one more time. Here's my x dx. Here's my x dx. So what I'm going to do is I'm going to write negative 1/2 du equals x dx. You with me on that? Come back here and do my substitution. Notice that x dx is minus 1/2 du. So I'm going to pull the minus 1/2. So then this guy becomes minus 2. Everybody see that? And then 1 over 16 minus x squared becomes u to the negative 1/2. Thank you, Layla. U to the negative 1/2 because it's 1 over. And Emily, is this going to be a dx or a du? Du. Okay, so we'll be all right on this. And now it becomes easy from here, okay? So then this is 2x squared minus 2. Integral of u to the minus 1/2. Two u to the half, and that 2 and this 2 should become a 2 times 2. 4 u to the half plus c, which is equal to 2x squared minus 4 square root of 16 minus x squared plus c. Guys all right on this? Sorry? Well, you divide by a half, right? So when you divide by a half, it's timesing by 2, and then 2 and then 2 gives you a 4. All right? Is everybody okay on this? Yeah? Is everybody all right there? Jonathan? Chris? All right. Next one you guys get to do, okay? And that's the last problem for the day. Sorry? Yes. You guys get to do this one. Now, let me just give you a heads up, okay? For your homework tonight, you've got some trig integrals that require trig substitution. I'm not going to do that until Monday, so you can hold off on those problems, okay? And then you can continue that on Monday. Okay? So, you guys get to do this.